I am Mrs. Madhvi Namanwar, working as a lecturer at Yashodhara Bajaj College of Pharmacy, Chandrapur, Maharashtra. Now I am going to discuss the topic non-steroidal anti-inflammatory drugs NSAIDs. Learning objectives. After completion of this video, you will be able to classify non-steroidal anti-inflammatory drugs and able to draw the chemical structure of indomethacin with its IUPAC name, able to outline the properties and uses of indomethacin, and you will be able to remember various preparations, brand names, storage conditions of indomethacin. Before going to topic, first we will see inflammation. So what is inflammation? Inflammation is a localized physical condition in which part of the body becomes reddened, swollen, hard, and often painful, especially as a reaction to injury or infection. The body reaction to injury or infection is a desirable thing, but this reaction leads to some undesirable effects, that is inflammation. So the signs of inflammation are here: pain, it gives heat, redness, swelling, and loss of functions. So these are undesirable signs of inflammation that are due to the reaction of body to injury or infection. So to overcome these symptoms or to treat these conditions, we need some agents. Those are nothing but anti-inflammatory anti-inflammatory agents. Anti-inflammatory agents are of steroidal and non-steroidal. Let's see non-steroidal anti-inflammatory drugs. So what is the definition of non-steroidal anti-inflammatory drugs? The definition is the drugs which are used to reduce inflammation and pain arising from it are called as anti-inflammatory drugs. How they are reducing the inflammation? So they block the synthesis of inflammatory prostaglandins by inhibiting cyclooxygenase enzyme to elicit their action. Cyclooxygenase enzyme is of two isoforms. One is COX-1 and COX-2. COX-1 is responsible for housekeeping functions of body, and COX-2 is the mainly responsible enzyme which leads to signs and symptoms of inflammation. When these NSAIDs are used, they are used in inflammatory conditions like in arthritis, rheumatism, rheumatoid arthritis, ankylosis, spondylosis, etc., and useful in mild conditions like headache, migraine, neuralgia, toothache, dysmenorrhea, etc. Coming to the classification of NSAIDs. NSAIDs are classified into three categories. One is non-selective COX-2 inhibitors, preferential COX-2 inhibitors second class, and third class is selective COX-2 inhibitors. So coming to first class, non-selective COX-2 inhibitors, those are also called as conventional NSAIDs. So first among these conventional NSAIDs again classified into different classes depending on their chemical structure. The first class is salicylates. So example of this salicylate drugs are aspirin and diflunisal. So these drugs having salicylic acid, that is orthohydroxybenzoic acid in their structure. So next class is pyrazolone derivatives. Pyrazolone derivatives example phenylbutazone and oxyphenbutazone. Pyrazolone. Students remember the structure pyrazolone. Pyrazolone is the 5-membered ring structure having 2 nitrogens in their structure. This is the heterocyclic ring. Next class, coming to next class is indole derivatives. Indole. So these drugs having indole heterocyclic ring in their structure. So examples are indomethacin and sulindac. Next class of drugs in this conventional NSAIDs are propionic acid derivatives. So these drugs having the group propionic acid, 3-membered carboxylic acid. So example of this group are ibuprofen, naproxen, ketoprofen and fluprophen. Next, coming to next class, that is anthralinic acid derivatives. So, anthralinic acid. Here, anthralinic acid is the orthoamino benzoic acid. So, the anthralinic acid containing drug example is mefenamic acid. Next group of compounds are aryl acetic acid derivatives. Example diclofenac. Next is oxycam derivatives. Example drug is piroxicam. Next, pyrrolopyrrole derivatives. Example ketorolac. So in this pyrrolopyrrole derivatives, two 5-membered pyrrole, that is one nitrogen contain 5-membered heterocyclic rings are fusion, two heterocycles fused together. So that is pyrrolopyrrole derivatives. So example is ketorolac. Next, coming to next class of drugs, preferential COX-2 inhibitors. So these drugs preferentially inhibit the enzyme COX-2. So example of these drugs are nimesulide, meloxicam, nabumetone. Next, coming to third class of NSAIDs, that are selective COX-2 inhibitors. Selectively, these drugs inhibit COX-2 enzyme. The COX-2 enzyme is the mainly responsible enzyme for inflammatory conditions. So compare with non-selective COX inhibitors, these selective COX-2 inhibitors having lesser side effects. So these drugs are more preferable to treat inflammatory conditions. So example of these groups are celecoxib, rofecoxib, valdecoxib. Next, we will see about indomethacin. So here I am giving the chemical name of indomethacin: 1 parachlorobenzoyl 5-methoxy 2-methyl indole 3-allyl acetic acid. So students, please pause the video and take the notebook. Try to write the structure of indomethacin by using this chemical name. So to write this structure, first you have to see what is the main ring. So here the main heterocyclic ring is indole. So you have to write the structure of indole with numbering. So here this is the indole structure with numbering. Then see at first position, so it having parachlorobenzoyl group. So remember the structure of parachlorobenzoyl. So attach it at first position. So here is the parachlorobenzoyl group at first. Next, at fifth position, it having methoxy group. So you have to attach methoxy group at fifth position. Next, it having second at second position methyl group. So you have to attach CH3 at second position. Next, at third, it having acetic acid group. So here it is acetic acid group. So this is the structure of indomethacin. So once again see the different groups on this structure. So here first position parachlorobenzoyl group, second position methyl group, third position acetyl group, acetic acid group, and next fifth position methoxy group. So this is the structure of indomethacin with its chemical name. Next, coming to the properties of indomethacin. So first we will see physical properties. So it occurs as pale yellow to brownish yellow crystalline powder, and regarding odor it is odorless. Regarding taste, bitter taste, and melting point is 155 to 162 degrees centigrade. Next, solubility, it is practically insoluble in water, soluble in alcohol, chloroform and ether. Next, it also shows polymorphism. Next, coming to chemical properties. So here, first take indomethacin in alcohol, then add NaOH solution. So it produces deep yellow color, and then this yellow color turns to green color. Again upon standing it turns to pale yellow color. So this is the identification test of indomethacin. Next, we will see the uses of indomethacin. So, it is used to treat symptoms of rheumatoid arthritis, osteoarthritis, acute gout, dysmenorrhea, ankylosing spondylitis, acute musculoskeletal disorders such as neck pain, myalgia, and pain in malignant diseases. Next, coming to indomethacin official preparations. Indomethacin capsules, official in BP and USP. So here marketed preparations of capsules of indomethacin here shown here. And next, indomethacin extended release capsules. These are official in USP. So one of the marketed preparation of indomethacin extended release capsules. Next, indomethacin suppositories, official in BP and USP. So here one of the marketed preparation of indomethacin suppositories. Next, indomethacin is also available in the form of injections also. Next, coming to storage conditions of indomethacin. Indomethacin is stored in well closed light resistant containers. Next, we will see some of the brand names of indomethacin: Ciplacid, Indocap, Indometh, Indocin, Indocid. So here the name is easily rememberable. So Indocap, Indometh, Indocin, Indocid. Thank you for listening with patiently.